So here I'm going to have h prime of x. Well, first actually, we have a cube root, and that doesn't look like something nice. So let's rewrite it. And by something nice, I mean we want to make it look like a general power rule or product rule or quotient rule. In this case, we just need the chain rule. So I'm going to rewrite h of x as a power. So it's going to be 2x squared plus 1 to the 1/3. Radicals become rational exponents. And notice that now it looks pretty much the same as before, except that our outside function, instead of being 2, the squaring is the 1/3, the cube root. So my h prime of x is going to be the derivative of the outside function, the 1/3. So my composition here is the inside function is still the 2x squared plus 1, but my outside function is the cube root of x, so x to the 1/3. So I take the derivative of this, right? F prime will be 1/3 x to the subtract 1, so minus 2/3. So we're going to take the outside function again. This is my outside function. So it's going to be 1/3 times the inside left alone to the negative 2/3. So the inside is the 2x squared plus 1. And then we're going to do times the derivative of the inside. The inside is my 2x squared plus 1. So h prime of x becomes 1/3 2x squared plus 1 times the derivative of 2x squared plus 1. So I'm going to have h prime of x is 1/3 2x squared plus 1. Oops, I forgot my exponent, to the negative 2/3, to the negative 2/3 times the derivative of my g. And this is 4x. And that's it. So to simplify it, h prime of x is, bring the constants, I should bring the constants to the front, so it'll be 4/3 x times 2x squared plus 1 to the negative 2/3. Since that's a negative exponent, let's rewrite it on the bottom. So I'm going to have 4/3 times x stays on the top over, this whole thing is going to go to the bottom, positive 2/3. And that's our derivative. All right, let's try another example. Let's find the equation of a tangent line. So find an equation of the line tangent to, let's say, h of x equals 2x minus 1 to the 10th at x equals 1. So finding the equation of a line. So the goal here is to find the equation of a line. So we want to be able to do y minus y1 equals mx minus x1. So remember, to find the equation of a line, you need a point and we need the slope. We have the point where we've given x. So for h of x, we know that x is 1. So in h of x equals 2x minus 1 to the 10th. What's y? Y is equal to h of 1. So plug in 1 in. So you're going to have 2 times 1 minus 1 to the 10th. 2 times 1 is 1. 2 times 1 is 2, minus 1 is 1. So you get 1 to the 10th, which is 1. So the point is 1, 1. So all we really need then is the slope. And remember that the slope is given by the derivative. So it's going to be h prime of x at x equals 1. But so far with the point, we have y minus y1, so y minus 1 equals mx minus x1, which is 1 also. So we need the slope. So this is what we need to find. The slope is h prime of x. So let's go find h prime. Since h of x is 2x minus 1 to the 10th, h prime of x. So this is one of those where I don't really want to multiply that out 10 times. So we're going to use the chain rule. So the derivative of this is we're going to do, again, we're going to do the outside function, which is the 10th. And then 2x minus 1 is the inside function. So the chain rule says take the derivative of the outside first. So I'm going to have 10 times the inside left alone. The derivative of this is 10 and decrease the power by 1. So it's 10 to the 9th. And the inside is going to stay 2x minus 1. But then I'm going to have to do times the derivative of 2x minus 1. So let's see, I'm going to have 10 times 2x minus 1 to the 9th times the derivative of 2x minus 1. The derivative of 2x is 2, and the derivative of negative 1 is 0. So I just get 2. So this tells us that h prime of x is, let's see, 10 times 2, so I get 20, 2x minus 1 to the 9th. So this is the derivative, and we want the slope is the derivative evaluated at 1. So plug in 1 in there, I'm going to have 20 times 2 times 1 minus 1 to the 9th. This 2 times 1 is 2 minus 1 get 1, so I have 20 times 1 to the 9th. So the slope is 20. Now back to our equation, right up here we had y minus 1 equals mx minus 1. Now we know m is 20, and so we can put that in here. Now we know m is 20 based on our work with the derivative, so we can plug it in. So I'm going to have y minus 1 equals 20 x minus 1, and solve for y. Distribute the 20 in and add 1 to both sides. So the equation of the tangent line is y equals 20x minus 19. So that's how you find the equation of a tangent line. So the chain rule is, this is how it works when you have a composition of functions. Now there will be times where you may need to use the product rule combined with the chain rule. So for example, let f of x equals, say, x cubed times, let's do x 2x plus 1 squared. Now this one we could multiply it all out, but let's use the chain rule to do it. And let me switch this function a little bit. In fact, let me do x cubed times, let's say, 4x plus 1 squared. So we could, right, multiply this all out, but let's try to use the rules that we know. So my hint here is that you have times. So I need to use first and foremost a product rule. And within that product, I'm going to have a chain rule. So f of x is going to be, and I'm going to write it a little bit more explicit. So the product rule says is the derivative of the first. So I'm going to say d dx of x cubed times the second left alone plus the first x cubed times the derivative of the second. And the reason I'm doing this is because here, when I do the derivative of the second, I need to use chain rule. So when we get there, we need to use a chain rule. So we're gonna go, sorry, that should have been f prime. So f prime of x is the derivative of x cubed, which is 3x squared, times the second left alone, plus the first. And now when I do the derivative of the second, here I need to use the chain rule. So I have an outside function. And I have my outside function here. And we have the inside function. So we have a composition of functions. So for this chain rule, I'm going to have the outside, so 2, the inside is left alone, and that becomes 2 to 1. So the inside stays 4x plus 1. Then my chain rule times the derivative of the inside. The derivative of 4x plus 1 is 4. But I'm going to come back and write it in another step. If you want to skip some of the steps because you're like, oh, I understand how to do it, that's fine. But for clarity, I'm just going for all the steps here. I'm hoping it's for clarity. So I'm going to have 2 times 4x plus 1 times, now the derivative of this, the derivative of 4x is 4 and the derivative of 1 is 0. So I just get 4. And combine everything, so I get 3x squared times 4x plus 1 squared plus, combine your constants first, so 2 times 4 is 8, so I'm going to have 8x cubed times 4x plus 1. Now here, in order to simplify, we want to think about factoring. So what do these things have in common? Well, I see that there's an x squared, and this has an x cubed, so it has an x squared in there. So I can take out an x squared. So I can factor that out. And notice that there's also 4x plus 1, and this has a 4x plus 1 squared. So this one has 2 of them. So I can take that out as well. So we're going to factor out x squared and 1 4x plus 1. So this is our common factor, so we're going to take it out. So f prime of x is going to be x squared times 4x plus 1. And the question is then, right, I'm looking from there, what are we left with? Well, I took out the x squared, so I'm left with the 3, and I took out one of those 4x plus 1, so I'm left with just one of them. Plus, here we took out x squared, so we're left with an x, so we have 8x. And we took out the 4x plus 1, so that's no longer there. So that's what we're left with. Remember, you have two terms, right? A term is separated by a plus or a minus. So you have this whole thing is one term, and this whole thing is another term. So you have two terms. So when you factor a greatest common factor, you should still be left with two terms. So we have this one plus 8x, the second one. But now we can simplify. So I'm going to have x squared, 4x plus 1, and then here we're going to have, what's this, 12x plus 3 plus 8x, and combine like terms. Now we're adding, so we're going to combine by adding. So it's x squared, 4x plus 1 times 12 plus 8 is 20. And so this is our derivative. So this one used the product rule and the chain rule combined. So what I want you to work on your own, so try it out. So try this problem. Well, what if you had to use a quotient rule? So let g of x be, let's say x cubed divided by the square root of 6x minus 5. So what I want you to do at home is find g prime of x. And I will stop there. I hope this video is helpful. Email me if you have any questions.